Alright, my name is Matt Distad, and this is my extra credit for ENG267 done in Matlab. The first problem here is calculating how many $5 bills a movie theater needs to have in order to have enough change for its customers 95% of the time, assuming that the customers have an equal probability that they will bring a $5 bill or a $10 bill. So basically the way it works is we have a variable for the number of $5 bills, and we're starting at just some value, and then we just run tests until we find a value that gives us that 95% probability. Turns out the correct value is 27. We're doing 10,000 trials. Basically what we're doing is a couple nested loop statements. We're assuming that we have 200 customers in line, and so what we do is we run a loop that will basically generate a random number, either a 1 or a 2. A 1 is going to mean that the customer has a $5 bill, and the 2 is going to mean they have a $10 bill. So we can say if x equals 1, we're going to add a $5 bill to our till. If x equals 10, or sorry, if x equals 2, then we're receiving a $10 bill, and we're going to reduce the number of bills, of $5 bills in the till by 1. So we run this loop 200 times, and then if ever the number of $5 bills reaches -1, that means we've ran out of $5 bills, and we've had a customer come up with a $10 bill, and he hasn't been able to get change, so we're going to call that a failure. And in that case, we go to the break statement here, and it's going to exit the loop, and then we have another loop here that's going to ask if the number of 5s is greater than 0, we're going to add 1 to our successes. So basically when we succeed, we're going to finish the loop, and then this is going to become true, and we're going to add 1 to the successes. If we fail, we're going to break out of the statement. This is not going to be true, and so we won't add 1 to our successes. And so basically this entire loop, we're going to run these 200 trials 10,000 times, and at that point we should have a number of success rates in our success variable, and then our number of trials will be 10,000, and we can determine our success rate at that time. So let's just go ahead and run this section here of the code and see what we get. So it's running 10,000 trials. It takes a little bit, and we see our success rate is 95.4%. We can run it again. It should be slightly different, but it's, oops, let's not run it that way. Let's run it this way. Should be pretty close the second time also. Yeah, pretty close to 95.5%. If we increase that number to 28, it'll be closer to 100%. Yeah, now we're at 96%, and 26. Gives us 94.4%. So the best number that is going to guarantee 95% of the time is going to be 27. Okay, let's go down to the next problem. Okay, this problem we are calculating. Okay, this is the next one. It's problem number 3. Basically, the scenario here is that we have 6 hunters, and they're shooting at 6 ducks, and we want to know the probability that a particular duck, our research duck, will be shot, and we also want to know how many ducks on average are going to be shot. The hunters can all shoot at any duck they choose. They can both shoot at this. 2 of them can shoot at the same duck. All 6 can shoot at 1 duck. That's pretty unlikely, but basically they can all shoot at any duck. So the way I did this is we have an array that is going to be 6 digits wide and then 1,000 lines long. So it's going to be a 10,000 lines. So it's going to be a 6 by 10,000 array, and it's going to be filled with 1s. And a 1 is going to signify that the duck is still alive. The next thing we have is a loop statement that is going to go through and generate random numbers, a series of numbers from 1 to 6, and basically those numbers are going to correspond to the ducks that we shot that round. So each of the 6 numbers can be any number 1 through 6. They could all happen to be the same number. They could all be different numbers. And we're going to go through, basically we go through, every time we generate a 6-digit number, we go through the array and we mark them with a 0, and those are the ducks that were shot. So by the end of this process, we go through 10,000 times, and we shoot all the ducks, and then we have this code down here which will count how many times the research duck was shot and how many times the total number of ducks were shot. So let's go ahead and run it, and then it'll display the results down here. Okay, so let's go ahead and run our code here. Okay, so the probability that the research duck will survive is 0.34, so about 1 in 3. 1 in 3 chance of the research duck surviving, and then the average number of ducks that will survive is approximately 2. So that's, again, about the same probability. 1/3 of the ducks will survive 2 out of 6.